Hello, AP Stat students. This is the video notes for section 1.1, reviewing learning objectives E, F, and G about marginal and conditional distributions. So 1E is to calculate and display a marginal distribution. 1F is to calculate and display a conditional distribution, and those are both for categorical variables from a two-way table. And 1G is being able to describe the association between two categorical variables by looking at their conditional distributions. So when a data set involves two categorical variables, we start by examining the counts or percents in various categories for one of the variables. So your definition of a two-way table describes two categorical variables and organize counts according to a row variable and a column variable. So that's why it's called a two-way table, because you have two things here, a row and a column. So in the example below, a survey of 4,826 randomly selected adults were asked, what do you think the chances are you will have much more than a middle class income at age 30? So here, the row, it goes horizontal, and the row categories are almost no chance, some chance, etc. And then the column categories are female and male. So those categories represent the two different variables. So question 2 asks, what are the variables described by this two-way table? Well, the almost no chance, some chance, that is just the response to the survey. And female, male, that would be their gender. So the variables described by this table are gender and responses to the survey. And then the next question here asks how many adults were surveyed. And that's going to be your total in the bottom right corner. We have a total row and a total column, and you won't always have those numbers in your table. Sometimes you'll have to add up to find them. This example has it done for you, so it's 4,826 young adults. The next definition is about the marginal distribution. It's one of the marginal distribution of one categorical variable in a two-way table of counts. It's the distribution of values of that variable among all individuals described by the table. Percents are often more informative than counts, especially when comparing groups of different sizes. So if I were to go back to this table, we wouldn't want to just compare 96 females to 98 males if we had drastically different totals for females and males. Uh, I gave an example in a previous video where I talked about saying something along the lines of having 2 male students that passed the test versus 10 female students that passed the test. But if I had way more females in the class, then you would expect more of them to pass the test in general. So we want to always compare percentages. So that's why we find marginal distributions. So you're going to use the data in the table to calculate the marginal distribution in percents of the row or the column totals. So if we're talking about distribution for females and males, you're using the 2,367, the 2,459, or if we're talking about the responses to the surveys, in referring to the different chances, you'd be using those totals on the far right that start with 194, 712, etc. So after you find those percents, you make a graph to display the marginal distribution. So that's what we're going to do. For example 1, we're going to calculate the marginal distribution for the responses. So I'm going to label a new little table here with responses and the percentages. Here are all the different responses, and here are all of the totals that I'm going to be dividing by. The total was 4,826, and then the number of responses that I'm looking at here is there's 194 people, male and female combined, that said almost none, because it's asking examine the marginal distribution of the chance of getting rich. So all I care is about the chance of getting rich. I'm not caring about whether it's male or female. So these numbers, 194, 712, those are the numbers that are in the far right column for the total. So We can divide all of these values, get our percentages. Make sure when you are finding percentages, you round appropriately. And then we have our graph here already made for us. But what this graph is missing is some labels. So let's label the title, chance of being wealthy at age 30, and then we do need to label both of our axes. So the left axis, or the y-axis, is the percent, and then the x-axis is the survey response. So there we have calculated our marginal distribution of responses and graphed that in a bar graph. Next, we're going to talk about conditional distributions. The conditional distribution of a variable describes the values of that variable among individuals who have a specific value of another variable. So in this, we are looking at the distribution of response rate, not caring whether they are male or female. Conditional distribution is when you're looking about a specific value. Another way to remember it meets a certain condition. So first you will select a row or column of interest. So it could be selecting the males and then looking at the distribution of response for just the males. That would be an example of what you would do. So you use the data in the table to calculate your conditional distribution for the row or the column. Then you make a graph, and you can graph it using a side-by-side bar graph or a segmented bar graph. What you see at the bottom of this page is actually a segmented bar graph, and then there are probably going to be plenty of side-by-side bar graphs in the textbook. Segmented is a little less common, but there's one in the notes for us to view there. So this example, we want to calculate the conditional distribution of opinion among males. So first we're going to do the males, but then we will do females after that. That way we can examine the relationship between gender and opinion. So we're going to do the males column first. So I'm looking at all of the numbers for males and the difference response rates. And I'm going to divide these numbers that are inside our table by the total of males. So I'm going to get all of those percentages by dividing 98 by 2,459, dividing 286 by 2,459. I get these percentages. I'm going to do it also for females. I'm going to look at the female numbers, divide it by 2,367, and get those percentages. This is what we would consider the conditional distribution, and then it's already graphed for you in this segmented bar graph. And then the last thing we would want to do is to analyze that relationship. So it says calculate the conditional distribution. We have done that. And then examine the relationship between gender and opinion. So right off the bat, what it kind of looks like to me is that men are somewhat more optimistic. The bars for men in the almost certain and good chance, it takes up more of this segment. But this isn't very statistical. We are not using really any evidence. So we're going to come up with a couple things to kind of prove that idea, or not prove, but kind of back up that idea. So first, we can say men are less likely to say only some chance, 11.6% versus 18. We could then say men are more likely to say good chance, both good chance and almost certain. Those percentages are higher. And then the last thing we notice is that the almost no chance and 50-50 chance are approximately the same for both genders. You can see that looking at the graph, and then you can back up the data, back up what you see with the numbers from your table. So that is everything for marginal and conditional distributions. And then the last thing we did was compare and describe the association between two categorical variables. So that should cover all three learning targets.